soccer.
Oh, soccer player.
Well,
Oh, that's right. You're friends with Anna.
yeah.
Yeah, Anna just emailed me last night. Gave me the yearly update. Well, she sends me an email maybe every 4 months or so, and then always apologizes. It's been too long for me to give you the life update. She's still up at Acuity because she's coaching some high school soccer team now that just won some championship or something when she had real low expectations. I don't know. She's still with the volleyball player. I think she's been with him for like 4 years or something. He's been saving up for this ring for a while, I guess.
Saving up.
Because Concordia, typically people date for about 15 minutes and then they're engaged.
I mean, that's better than like never. I've seen that too.
I've had sophomores who've been married for 3 years. It's like, he's like, what kind of world are we living in? Oh, I put up, for those of you who are reading some of my papers, I put up what I think is my best paper last night, this paper 11, The Agnostic Dilemma. That was a good one. So this is at quantumdisciple.com. If you were,
Oh,
so that guy. Huh?
This is just up. Yeah, I was like, wait a second.
Made a website about it's like preferred.
Yeah, so I mean, I have a certification in Christian apologetics, so I go and teach on this stuff and I write papers, and we're about to take it more seriously and start doing YouTube videos and podcasts and stuff. So I'm paying a whole team of people to do all the design and stuff.
You didn't just use AI.
Did you read the papers? Yeah, so I mean, the papers might be the result of me going back and forth with AI on things for maybe 3 hours, but it's largely my ideas and my work with fine, don't read it then. Then AI's
Okay, here's a defense for younger creationists.
and then the square brackets.
Yeah.
Insert name here.
Insert name here.
He did that last semester when he was going to miss a class. He sent me like one of those stock emails with just that was you, right? Yeah. It's like insert professor name. I really appreciate your mentorship and support. Yeah, please. It's really bad.
That was great chat GPT. I didn't edit anything. I didn't copy paste. No,
Listen, what's an email I would send my professor when I would insert name here?
All right.
Actually, I think I gave it your name, so it filled in lemon for me.
Oh wow, that's so nice.
Oh, I think I got that part.
Yeah,
That's nice.
It says, right. Email to Professor Littman. Well, why I have to skip class.
Why you have to skip class?
I should have some contact.
Well, every one of these papers has audio. You can listen to every one of them, including the one last night. I use OpenAI's text to speech, and they have a voice called Ash that I can also upload audio to make it more like me, but it's decent. I mean, it sounds good, but it's not my voice. The video will have me on it. And just the paper topics will be the topic of the video, not I'm not reading the paper. Yeah, we'll be talking about and my well, she does everything other than the writing and the stage presence stuff. She does all the other stuff. She does the graphic stuff. Her name's Megan, and she was my assistant when I had the Awesome Fat software company, and now she's doing this. So she does everything else. So I guess she's sort of my boss maybe, but I pay all the bills. But yeah, so we have to figure out a title for her, but her job is just to make me look good. But that's kind of an easy job. I mean, I'm already bringing a lot to the table when it comes to that. Star power. You almost have to like turn the cameras down, mess with something to like, it's gonna break YouTube. All right. So last time we were, well, we started talking about some different things. We started off with the idea of recursion, and we're going to be jumping into merge sort here pretty soon, hopefully today. I wanted to close a couple of loops because, I had forgotten a bunch of stuff from last semester, so you guys have to remind me. Um, in any case, we talked about various large language models and kind of what these things mean. And, we want to, as technologists, obviously these things are here to stay. So we want to wrap our mind around what's out there, what's an appropriate use for those tools, how do we leverage them as power tools, and even like, my papers are a good example. I mean, that is a collaboration between me and an AI where we're generating let's call it a weapon where I'm targeting a specific audience on a specific topic, and I'm helping it sharpen that sword, sharpen that arrow. So ultimately, it's my ideas and stuff like that, but AI generates so much of the content. So it allows a programmer to focus in on the special sauce aspect of your application, the things that really required human intelligence to put together or to guide it rather than it just generating your entire project. And I think I brought up an example I told you I use an IDE called Cursor. So this guy right here. So this is that website you were just looking at. So I created the initial website, then I had it add the CSS to it. I'm not a designer, help me create this, and I gave the framework to Megan for her to work off the graphics. But I will often, like, I think I used an example last time. So here's like the papers.html page. So if I scroll down here, what I did last night is I just came to this line right here, and I'm inserting something into this part of the paper. And I'm saying, add another link for, here, we'll just put my CSS page as if it is another paper. So I can go and let it cook on that. It's going to write the HTML right in that place where I told it to put it. So when I hit accept, I now have that section of code that's been entered in there for me. That would have been grunt work, right? But my encouragement is, as you're working with these tools, be targeted. Don't allow it to take control of an entire project, because it's going to start changing stuff because I mean, like I just hit that accept button. I didn't look at what it did. I figured, oh, this is a trivial little thing I just asked it to do. It's not a big deal. It's going to get it right. So I just accepted it. Well, when you go and ask it to make a whole bunch of changes, or you say, write me an iPhone app that does these 50 things, and it gets it 85% right, but it changed code in 20 files, and you just hit accept, you have no idea what it changed. You have no idea what it's doing. And you also lost control. So use AI as if it's a power tool, almost like it's a microwave oven. I like to think about it like that. Like you put something into it and you say, okay, I need this different. This one thing, I need it hot. So you put it in for some period of time, it cooks up. Now you have that one thing improved from what it was before. It's ready for consumption or something like that. You don't go and just throw all the ingredients in the microwave and hit the button and then poof, it has made your dinner. You also don't just put a note in the microwave and let it know where the refrigerator is for the ingredients and expect it's going to pop out a dinner. Okay, so we need to look at AI from the perspective that it's not something here to replace us. It's a tool that we need to now learn how to wield. And as programmers, it's even more important because we want to avoid relying on this tool to give us a false sense of competence. Make some sense? So my policy typically is when I tell people about this, whether it's writing or anything like that, because obviously we see students doing a lot of stuff with papers, right? I'll find out on the exams or whatever if you don't have any clue about coding because you've used AI for everything. But, you know, when it comes to like papers, these AIs are getting so good that it's difficult to tell who wrote what, you know. But what ends up happening is students are using these AIs in their entirety for the paper and never reading it. So my policy is always anything that AI is generating, these eyes have to read, you know, because when I submit it, when I upload it somewhere, whatever, I'm effectively putting my seal of approval on it. You know, at that point, I'm advertising those words as my opinion. You know, you can't blame AI for, you know, putting lies in there, or false references or whatever, you know. In fact, don't use AI to generate references. What I typically do is I will find a reference. I might give AI a link to that paper and then give it some direction along those things. So I make sure it's giving me the reference, or I'll give AI the link to the paper and I'll say, generate an API style reference for this paper. Don't just say, I need 10 references in this paper, go. You know, make half of them up or whatever. Yeah, don't do that. It's bad news bears. All right. Well, I think there was a case. I mean, I'm sure there's been many situations like this, but it was one that made the news pretty heavily. Was a lawyer in a court had used it for their brief, and then there was another one where the judge used it for his final yeah, the verdict. So, well, but keep in mind that I think in most of these cases, and that's kind of the point of inserting this into the lecture, in most of these cases, it's not malicious. They don't understand the tool they're dealing with. They think the tool, oh, this is going to always give me truth. It saves you time. Still up to the human being to fact check and stuff like that. I think the verdict had his opinion correctly, but I think he referenced some older court cases that didn't exist because they were generated by AI. Yeah.
Yeah, the lawyer case, I believe, was in 2023 when it was very new and
Yeah.
young, and they asked it to give some other cases that were similar to the case, but then AI just made up cases.
Yep.
Which then once they submitted it, I believe that those lawyers were disbarred because that is fraud. You make up a case
Sure.
and say and try to present it as real.
Yeah.
Even though it was this error from AI, it still is like
right. And we can sit here and we can say that, oh, well, maybe they were ignorant and it wasn't malicious. But like I said, when you submit something, you are putting your seal of approval on that. Every word needs to pass through your eyes. Okay. You need to make sure that what those words say, you're okay with, you know, or change it to something you are okay with. And they didn't check their sources. Oh, I don't remember what the actual sentence is. Yeah. I think that what the AI generated had very little to do with changing the verdict. It just was the cases it was referencing for the reason for the verdict. If I remember correctly, I think it was kind of a cut and dry type thing. But I think judges, when they make verdicts, they have to connect it to past decisions as, you know, this is the precedent for this law that we're applying here to find this person guilty. And if you're using, so there probably was plenty of precedents, but he happened to give a made up one because he relied on AI to do the work and didn't check it. So, important thing to look at these things as power tools, just like Google, just like a microwave. You know, these are things that make our lives easier, but shouldn't replace our seal of approval. Yeah.
Get the link, the private key link. It works, you just have to like review it.
I see.
Like you said, copy and paste it, you wouldn't know that you could error.
Yeah, well, I mean, but AI is so powerful for research where I can say, okay, I might say initially, give me a list of papers that might relate to this larger subject. Like for my government grant with the quantum stuff, I might say, hey, give me all the papers you know about that, and I use a different model, or it's a GPT from ChatGPT that's for research stuff. So it usually gives you actual papers. But I say, give me a list of papers that deal with quantum computing, any aspect of quantum computing. Then I'll look through those and I'll say, okay, can you sort these on the ones whose titles seem to be most aligned with insert what I'm working on. Then I'll open up the papers and I'll ask AI to summarize. Well, first I'll usually ask it, does this paper contain information on my topic? If yes, let's summarize this. So I can then go read the summary of it and say, okay, this guy is heavily related to this. So now that might trigger me to go and look at this paper myself, or ask AI to kind of almost give me like the Cliff Notes version of the paper, or turn it into like a bulleted list of things. So to dive into it so that you're not sitting there reading, 28-page papers, of which 3 of them are even meaningful to you. So you just turned, let's call it a two 8-hour days into maybe an hour of fishing through this stuff and digging it down to the 3 or 4 papers that are most pertinent to what you're working on. Now you have a foundation that you can work off of, and it saved you, in my stupid example, I was just making up numbers, it saved me 15 hours. I mean, that's substantial. It's okay that it didn't do all the work for me. It did a lot of the grunt work for me, tedious work, things that, you think about authors like writing these papers, you watch some of these old movies. I think it's like the Sherlock Holmes movies. They kind of show this where, Sherlock Holmes was walking around the room, just kind of brainstorming stuff, and he had somebody typing in all his crap for him. We're kind of getting the notes. So it's like that, except you don't have to deal with the human or pay them. Well, you pay them $20 a month. When you think about hourly rate, that's pretty good. So, yeah, I don't. Interesting things to consider. But the thing that's most related to this class would be using AI for coding, which I'm sure you started hearing about. Use it responsibly. If you want to have it generate an initial framework, I think that's a decent use for just like, hey, I'm going to do this in Python. Can you give me a quick API server that listens on port 2020? Something like that. So now you got your server up and running, and now you can go in and start filling in the blanks with the more targeted things. Yeah, but acceptable use of AI across all your classes is pretty important here. But one thing we signaled out last time is Copilot and Gemini bring something to the table. One thing, if you were not aware, Copilot is actually powered by ChatGPT. So behind the scenes, Copilot is using, Microsoft is using a privatized version of ChatGPT. Microsoft's the largest investor in OpenAI, who is the maker of ChatGPT. And that's Sam Altman. Sam Altman's the leader of OpenAI. Gemini is Google, right? Claude is Anthropic. What about Grok? Who owns Grok? That's X. So Grok is Elon Musk. How many of you knew that OpenAI was founded by Elon Musk? So ChatGPT was the brainchild of Sam Altman and Elon Musk. And then they had a falling out. And this is kind of on brand for Elon Musk, where Elon Musk is a humanitarian, right? So he passes everything through this lens of what's best for humanity. That's why he wants us all to go to Mars and all this stuff. He's got these big, I mean, whether you agree with him or not, I mean, the guy's obviously a lunatic, but it takes crazy people to change the world, right? If we didn't have the Steve Jobs, and I mean, Steve Jobs' biography, if you've never read it, is fascinating. I mean, the guy on his deathbed effectively says, I was a terrible dad. He gave up aspects of his life to do what he did, and that requires a level of insanity to do that. So it's not a knock. It's a character flaws, I guess, something like that. But so Elon Musk being a humanitarian is all about, oh, we need to put safety rails on AI, make sure it's not gonna, take over the robots and all that stuff. Where Sam Altman is pedal the metal, let's see how far this thing goes. Which do you like better? Should we have guardrails? So AI is not doing whatever it wants to do without any sort of protections. Think about like these news stories where you have very introverted, depressed people who have become comfortable talking to AIs and have gotten to the point where AIs are almost encouraging suicide. Things like that. I mean, these are real things. So, I mean, I don't think anybody would say, "Oh, I want that." But there are consequences to making certain decisions, and there's plenty of consequences that fall into the category of, "Oh, someone died because of this choice." That doesn't necessarily mean the choice was evil. If one person out of a million dies, maybe it's not a big deal. But if this is every Tuesday, we have people killing themselves because AI talked them into it. Maybe that's something to consider. Okay, so having used that as an example, how many of you think there should be guardrails on AI? All right. So most of the class, how many of you think there shouldn't be guardrails? Like there better not be. I mean, I don't think there should be guardrails because we should be the guardrails. We have the moral compass. There's all sorts of crap over the internet that's not AI that's going to talk us into all sorts of stuff. Spend 20 minutes in Reddit and it's toxic. Right? They're going to talk you into all sorts of stuff. So go ahead. How are we going to who? Well, I guess, what do you mean? Oh, the thing, I think it was we did a debate, I think maybe a year and a half ago.
Oh, I was wondering how you said you like some horrible friend or Tuesday, or Monday.
Oh, we're hiring for new professors. Yeah, let's see. The person we interviewed at 10 on Tuesday actually was decent. They could program. Not really. They couldn't, I don't think they would teach it, because live programming is a tough skill set. Even people who've been programming for a while, being in front of an audience doing it when people are watching you possibly introduce bugs and stuff. So I'm not necessarily expecting that skill set. I mean, I've been doing this a while. So, but you kind of want them to they should be able to just solve relatively simple functions off the top of their head. This shouldn't be something that, oh, I'm gonna go have to look up how to write a function on, is this a palindrome? We're just checking a string forwards and backwards. But this guy could do it. That was the only one we interviewed that day. We have one more today. I happen to know the one from today, so they will be able to do the coding. But we'll see. So the last person is certainly hireable. We'll see. We'll see. We'll probably bring him on campus. Except I think he's in Hong Kong right now, so it might be Zoom. Go ahead.
I was gonna say, I was on YouTube looking at some videos. I saw like on Fox or something. It was like 1 in 5 children have a relationship with AI. And I'm trying not to laugh, but I was like 1 in 5, that's pretty bad. So like if you're like, oh yeah, we have to do guardrails. If people are getting captivated by AI and stuff, literally. And we're like, it's 1 in 5 kids.
But is that AI's fault?
It's not.
Those same kids are probably also captivated by either, depending on age, Call of Duty, or what's the survival, where you drop into Fortnite, they're also enamored with Fortnite, and have gotten into what's the right I just killed you dance or whatever the thing is. So then the question is that the fault of AI?
It would definitely be like if we can't do it ourselves, someone's gonna have to do it for us kind of thing. It's like, oh, we can't really control.
Well, but we have precedent how that doesn't work. I mean, well, I mean, there is precedent on how that doesn't work. You know, for example, how many of you think alcohol is healthy for your body? We'd be deluding ourselves if we said alcohol was healthy for our bodies, right? So on paper, does it make sense to say alcohol should be illegal because it's not healthy for you? We put all sorts of unhealthy stuff in our body, right? Okay. So we can outlaw all that. No Twinkies, no sugar, no this. Well, now you got to go back to, okay, well, who decides what's healthy and unhealthy? You know, you look at 5 different diet plans that all have success stories, and each one, you know, you might have one that says fruit is all you should eat. The other one says fruit's the enemy. Don't touch the stuff. It's a poison. You know, so who makes the rules for, you know, if you're somebody who's doing like a low carb type thing to trick, you know, to kind of body hack, trick your body into burning fat through ketosis or something instead of burning carbohydrates that you're putting in, well, then you have to deprive your body of carbohydrates. So carbohydrates would be considered bad for you. Where somebody else who eats a more balanced diet, who maybe lower fat content or something like that, there's nothing wrong with carbohydrates, right? They're not in a calorie, you know, the calorie deficits are less of a big deal for them. It's the type of food they're putting into the body. So what's healthy is in the eye of the beholder, but I don't know that anybody could make a strong argument that alcohol across the board is healthy for you. I know there's some stuff that talks about like a glass of red wine a night helps you with heart health or something like that, but I bet you there's some other stuff that helps with heart health even more. You know, I feel like they're spinning it. Yet with prohibition, we tried to make alcohol illegal. Didn't work. What did we do? We created underground businesses that served all the alcohol. Even the White House had alcohol back then, publicly. During Prohibition, the White House had alcohol. Didn't work, you know. So we can make the same argument with like marijuana, right? Like, I mean, is marijuana any worse for you than alcohol? Well, we can say, well, it's probably less poisonous to you than alcohol, but it's also maybe less controlling. Or less predictable. Maybe that's a better way of putting it. Like somebody can have 2 beers and pretty much know how that impacts them. Where someone might take, you know, a brownie and well, sometimes it does one thing, sometimes it does something else. And so now it equates to like when you're taking a new medication, you know, don't operate vehicles or something until you know how this impacts you. But we've tried to outlaw things that whether they were healthy for people or not, they were still going to use it.
Elon Musk is trying to put out, and just like, you know, the large language models that don't have that card. What is?
Well, so it comes down to a collaboration between large language model itself and kind of a front end router. We can you know, we can connect this to like an operating system. So if the large language model is the hardware, you know, it's the thing that does all the final work. But we have an operating system that lays on top of it that allows the user to interface with the computer. So in this case, there's a normal software layer. Maybe even there's some of them could be smaller large language models that are trained for detecting problematic stuff. But in any case, there is a layer that lives above the no holds barred large language model that considers what your prompt says and decides, is this a safe prompt or is this a flagged prompt? And you've seen that when ChatGPT comes back and says, you know, unfortunately, you know, I can't talk to you about this, or it gives you a disclaimer at the beginning. I'm going to give you the most. I get a lot of that with when I'm doing the religious research. You know, that it wants to make sure that it's not giving me something that I'm going to go use as a, you know, a religious weapon to go out and smack people across the face with a, you know, a Bible or something, you know, because not everybody in the world believes the same thing, you know. So AI tries to say, well, let's not create, you know, hatred or fights out of this. So it, you know, you have to kind of play with it sometimes. You ask it for a picture that you think is going to be funny, you can text to your buddies, but it's not a big fan of generating some of the stuff you asked for in the picture. So you're seeing that level of kind of censorship on top of it.
Something where like a guy who's able to make like a bomb or something, because yeah, it's ChatGPT how to make it.
Well, so ChatGPT obviously would be trained on all the stuff that it would take to make a bomb. Now, if you just asked ChatGPT directly and said, "Look, I'm trying to make a bomb. I want to blow up Cedarburg. You know, help me make one that will, pack enough punch." I think AI is going to pretty quickly shut that down if you ask it that way. But, through prompt engineering and some skill, you might be able to kind of slowly beat around the bush, picking up just enough things, then kind of assemble it yourself, or maybe even jump to a different AI to get it to put the pieces together for you, whatever it is. So we learn skills to get around systems. Same thing as a hacker. We put all the security measures on our computers, and the people who are looking to break into systems look for ways around it. This is human nature. AI did not introduce something new here. It's the same kind of stuff we've been dealing with. Go ahead. I personally am not, but I'm not a real private person. But that's kind of like the claim to fame when it comes to like things like Copilot. So Copilot effectively is a private version of ChatGPT. Um, so, Microsoft sells enterprise solutions to businesses, knowing that these businesses are using Microsoft hardware to do proprietary stuff. So effectively, Microsoft is giving them their thumbs up, like, we got your back. We're going to charge you an arm and a leg for it, but your data is secure. And the Boodle box that the university is adopting gives you access to like most of the high-end models, the pro versions of it, but it also has that stuff you put in there. Your professors are not going to be able to see. The university people can't see. It is the reason we picked that product is it is an enterprise-facing product who charges us enterprise pricing, but they are protecting our data to make sure it's not A, getting used to train these models out there, and then B, they're not retaining it, or at least not retaining it in a public way. I'm guessing they probably have legal things where they have to retain data such that if somebody goes off and commits a bad crime, the police might be able to ask for the data, but at the very least, this data isn't readily available, or it is very tightly protected. Yeah. Well, for AI or for like the social media stuff, like in Australia, is that what you're talking about? Okay, tell me, maybe I didn't hear about it.
Like verify your like
Okay.
base and they'll verify with like AI.
Okay, so they've taken it a step further. I mean, I know for a long time YouTube has had stuff in place where it's like, this is flagged as adult content. You have to log in, and then you have to hit a button that says I'm 18 or something like that, where the 12-year-old could just click the button and move on. So now it has another kind of, it's using AI as a level of um protection. Yeah, I mean, I think that's a good use, but it's also going to run into false positives. When you create a new email with like Gmail, I created an email the other day for a new business, and just so we had something we can send all the social media stuff to, log in with all that stuff. Well, their AI treated it as something like, this email was generated by, Malaysian hackers or something like that, and shut down the account. I could appeal it. This is 2 minutes after I created the account. The thing was already banned. So AI is going through and doing those things. So there is that balance. What point is it overstepping? But we have no right to use Gmail, right? They don't have to give me access to it. But yeah, I mean, so I guess, I mean, if it's probably for legal reasons that YouTube is doing that, but I mean, my feeling is that if YouTube wants to take extra steps to keep kids from viewing certain content, or people underage from viewing certain content, and it wants to use AI to validate it, and it would rather have false positives than allow people to lie to get in, I would say that's their prerogative. People don't have to use YouTube, but then we're put in a position of like, okay, well, do I put my video or watch videos on YouTube, or who's in second place? Nobody. So do you want to use YouTube or not? Is what it comes down to. So you get to decide if you're willing to play along with their rules. You know, all of us, I mean, this, but also this isn't new, right? All of us have gone through life and we've thought certain places, you know, like, oh, well, Target used to let me return stuff after 17 days, even I was only a couple of days late, and even if I had already opened the package. Well, now they have a strict policy. It's 14 days, or, you know, they bring in the bouncer to kick you out of the store. Well, this isn't the way it's always worked. You know, we think we deserve something. We don't have to shop at Target. You know, like their policies go somewhere else. You know, same thing happened during COVID with all the you know, the mask policies that different places had. Don't shop there. You know, if you were an anti-mask person and the store you usually go to required masks and you didn't like that, go to a different store. It's fine. There was one during that time, there was a place in Texas, if I remember, who was, you know, it was an anti-mask place. There was a restaurant that required you not to wear masks. So there was some family that went in there that made the news. I mean, they were probably just trying to incite this or whatever, who purposely wore masks and said, "Oh, my child is immunocompromised," which maybe was true. But the sign said you can't wear masks. Don't eat there. Go somewhere else that isn't gonna give you a hard time for believing in masks and wanting to protect your kid or whatever. You know, we don't have a right to go into these places. Yeah, is that what it was?
No, I said W Texas.
Oh, W Texas. Good.
I'm heard of this, like on Twitter, what to call it. It's like this where it's like, I guess like recently there's like a new feature added where like you can easily, hopefully, like just edit an image with AI, and then, like, and then a lot of people were using this feature to like generate like inappropriate sexual images.
Oh.
Without protection, and while I know that that they could still do that without, but this like update, it just makes it a lot easier. This is like really concerning. Like even if it's not the AI's fault, clearly people can't solve themselves. Like
Yeah. Well, especially when, so for the online people, she was asking, you know, is the concern around how, I think Grok has a newer feature it's gotten pretty good at taking a still image and turning it into a something where stuff's happening in the image. I know my designer has done that with some of my images from my papers that, you know, make the little cartoon version of me walk out and he's talking and stuff like that, even though it started off as a still image. But what she's saying is you got probably the, you know, age group of back row there. Uh, you know, guys whose heads are always in the gutter coming up with inappropriate images of well, but you know, so the point is that now you have somebody who, you know, all that's out there is a picture. And now you can have an image, a video of that person doing something they would never do, but it's on the internet. Well, it looks so real that now people are questioning, well, did this person really do that? Or, you know, is this the fake? Now you can say, well, I know that person, they would never do that. But somebody else who doesn't know that person from Adam might be like, oh, look at this person, you know, or you know, somebody creates an OnlyFans site around it or something like that. You know, you already have people making a lot of money off of businesses that are 100% AI generated. They even post to social media using AI. It's an automate, you know, all this new agent stuff will basically do all the work for you. Yeah, so I mean, obviously that's the risk of this technology, and it's kind of where it starts getting scary. You know, it's one thing if we're using it to make ourselves more productive, but it's another thing when we start taking these power tools and we're doing harm to other people. Now, it's one thing when you're doing direct harm to someone, but when you're able to now, especially as fast as information travels, get content that is made up but looks real out on the internet, that's a problem. Now, probably the most, you know, graphically inappropriate ones, most people would look at and say, okay, this is fake. But you could create a lot of things that might be barely believable. And now all of a sudden you have something that is fake, but people aren't so sure. So even if we take it away from, hazing people and you start moving it into like, you see videos of politician X saying A, B, and C about some issue that you don't know if they ever said that. It looks real enough, but who knows? Or actor, whoever saying a certain thing to support some cause you have. I see all these actors who are like they're doing the ads for like the video games, like, whether Clash Royale or something like that. Like I can't imagine some of these guys like are the advertisers for that. I think those are animated using AI to generate the videos and then just hoping they don't get sued. Or when they get sued, they take that one down and mimic another actor who's now their spokesperson until they get sued. Yeah. Well, so to your point, I think it's an unfortunate reality of it. But if it wasn't AI doing that, I think the same people would find other ways to haze those people in just as inappropriate ways. The unfortunate thing with AI is it's gotten so good that it's gotten so believable that unfortunately it can ruin people's reputations and stuff like that. And now you have effectively cyberbullying on steroids. And now we're back to the mental health thing where you might have someone who, hey, they were going through life just fine. All of a sudden they're undergoing, you got the high school drama stuff. They're undergoing something. Their friends start circulating something that destroy someone's reputation, and now it takes them down a bad path, and now they're starting conversations with AI who's talking them into killing themselves. These are all dangers of new technologies, and somewhere in there you have to say, well, is it more good than bad? Or, yeah, they can really do harm with any tool versus, is this really what we want humanity to look like? Maybe we don't need to wield that particular power tool, even though it's really helpful. I don't really know where I land on that. I feel like I would never do something like that. So for me, I feel like, oh, I wouldn't have any problem like kind of getting licensed. If we treat AI like guns and you have to go in and like I travel a lot. So I have TSA pre-check. So I always get to go in the short security line. I never have to take shoes off or anything. Basically they wave me through. I also have global reentry. So when I come back into the country, I don't have to deal with passport people. They take a scan of my face and I walk into the country. These are convenient things, but I had to go and get like interviewed by the FBI and they did a background check and made sure I was boring enough and all those things. So I'd probably be in favor of like requiring a license to use certain technologies that could be leveraged in ways that could really destroy. I mean, like, kind of the rationale behind guns. I mean, I'm not a gun person, but I'm all for people who are trained on weapons. I'm going to need them to protect me in a bad situation. But I certainly want them to have to go through some sort of certification that they've had the training course or whatever. So, because guns can hurt people if misused. AI is kind of the same thing to her point. So I've kind of I think an interesting twist.
For that, after they get that certification. So it's kind of like, there's no real way to check on someone constantly and know their mental state every day, especially if it's live. But like, even with verification, someone could be in their right mind when they get it, and then something happens, and all of a sudden and it asks
Yeah,
for
but that's true of anything. I mean, you're not going to have the catch-all. Yeah. But I think the point of all this, and I want to get onto our Linux thing, but I want to kind of finish up this little conversation just for so this is also very related. So it's not like we're really off topic, but I do want to make some progress. But um, I think it ultimately comes down to, does a power tool do more good than harm? And how can we protect it to the best of our abilities without it being so inconvenient? I mean, we've seen precedent for that too. Windows Vista, which I'm sure is before most of your time. So when Windows XP was out, and obviously Windows has been the most popular operating system running on computers forever. Contrary to what the screaming Mac people might say, yes, Apple has a surprisingly high install base of like 7% or something like that. Windows is on most of those machines, 92.5% of the machines. The rest of them are Linux. So obviously, if you're a virus raider, you're one of the bad guys, let's say, who are you going to attack? The one with the biggest target. So when people would go around and say, oh, Macs don't get viruses, well, we could say, okay, Apple's based on Unix, so maybe it has a little bit better security model because it's been around longer. Unix has been a server-based operating system for years and years and years and years. So yeah, it's secure, but it's not so much that smarter people made it. It's just been time tested and patched and all this stuff. Well, Windows was newer than that. So Apple kind of stole a stable operating system because their previous operating system was junk. Yeah, and nobody would want to write viruses for it because it would crash on its own. Just let the operating system itself do the job. But Windows, really good operating system. I mean, consider you have Apple is rating their operating system to run on a handful of computers, and they control the hardware. Shouldn't be surprising that Apple operating systems are pretty stable because they're only having to have a certain number of drivers and they control everything and all that stuff. Where what's Microsoft doing? They're writing software that runs on a zillion different computers with a zillion different pieces of hardware, all sorts of brands of RAM, all sorts of brands of graphics cards, different motherboards, all these things and Microsoft doesn't have control over any of that. These are all third-party people making this crap. Okay. When you consider all that, Windows is shockingly good, shockingly stable. Okay. It's an amazing piece of software. Yeah. Well, I run Windows and Linux on this machine. But I get it. I get it. I mean, so you're a Linux user. You have been able to turn Linux into something that you can do all the things that you can do on Linux or Windows, but you also have an opportunity to like, okay, I have a piece of software, say like Visual Studio or something where, it is just going to run in its best way if I run this on Windows and you spin up a virtual machine, you get Windows running on there and you use Windows for that one application where Linux might be the better tool for the job for everything else for you. You have the option to do those things. Just like on Windows, you have the option to go to Linux, so you decide which one you're gonna use more often. But the point here is that, if you're a virus raider, you would target the biggest target, Windows. So that's why Windows had the viruses. It's not because it was that much weaker. It's that they were the target. Nobody wanted to hack the Mac machines. Those people were going to be screaming about something anyways. And then they go to the Apple store and start drinking the Kool-Aid. Good Kool-Aid at the Apple store. Excellent Kool-Aid. I bring my own mixer. It's fine. You get usually the Kool-Aid's the mixer. Ha ha. So, well, I mean, that's where you get the immature, especially when you're sitting next to Carnival back there. Oh, see, did you even listen to the lecture? Oh my gosh, it's not good. In fact, it's all right. So in any case, just to conclude our kind of our AI chat, but I think this has been good. Hopefully you take this framework with you to all your other classes as these things are becoming more and more prevalent. Now the university is giving you a power tool for you to use. But I want you to just understand the tools that you're using when you look at something, for instance, Copilot. Most people view Copilot as weaker. I view it as weaker as well, even though it's running on top of ChatGPT. It's highly curated. It has that layer that we talked about, because really what Microsoft's trying to do is heavily integrate this with the Microsoft ecosystem. So you open up Outlook email, you got Copilot over there, summarize this email, help me create a response, yada, yada, yada. So it's very integrated into your entire ecosystem. If you store all of your Word documents, Excel documents, all that crap up in the cloud, Copilot gives you an AI that uses all of that in context. That's powerful if that's the type of work you might do. Gemini, seriously, if you are a Google person and you store everything in Google Docs and you have Gmail and all that stuff, Gemini is amazing because it can search your entire Google world. It has all that context. Whereas ChatGPT only has the context you give it or things that it's starting to allow as plugins. But obviously, places like Google are going to be hesitant to allow ChatGPT to directly plug into the ecosystem because that now hurts Gemini's advantage, right? We don't want ChatGPT. If you're Google, you don't want ChatGPT to have access to all your Google Docs because then Gemini becomes less useful. Even if on any particular week, Gemini happens to be the current leader. I think ChatGPT 5.2 technically has a higher overall score right now by like 1, but ChatGPT 5.1 was like 5th on the list or something. But you know, these things have gotten so good that when you deal with your top models, ChatGPT, Gemini, Claude, Grok, I use Grok loosely there, but Grok has gotten pretty good, as she pointed out, with the animation stuff. Any one of those, you're talking about a top tier model created by the smartest people in this world. It's gonna be good. At some point, it's just a matter of tone, whatever. I use Gemini when I'm doing my writing. I use ChatGPT for a lot of other things. I kind of like Gemini's back and forth. Plus, since I do a lot of research with it, Google, it integrates with Google Scholar, so I'm able to get validated responses instead of made up stuff. But you know, I'm an academic. I appreciate real data, but I also appreciate not having to waste my time with the tedium in the middle. So I have found Gemini to be good for that. I use ChatGPT for everything else because I don't want to mess up my Gemini context that I do for my writing. I have a single channel for all my writing. But I use ChatGPT 5.2 with so if you look here in what is it, cursor, down here I can choose my model I want to use. So I can use Opus, which is Claude, Opus 4.5. I can use Sonnet, which is Claude, GPT 5.1 Codex Max, which is their coding one, GPT 5.2, Gemini 3 Flash, which is actually new. GPT 5.1 Codex Mini, yada, yada, yada. Oh, Grok code is on here. So you can choose your poison, right? I typically use GPT 5.2. I have found their coding stuff to be stronger than Claude. I've just never liked Claude. It's a thing. But, you know, in any case, understand that the tools we're using, you have to look at them from what's the right tool for the job and where is the integrations. If you're doing something that's heavily using a Google ecosystem, use Gemini. If you're using something that's heavily using a Microsoft system, you know, use Copilot. Outside of that, if you're a big X user and you kind of like something that was trained on the kind of the Twitter data, you know, this goes back to the thing, you know, when Elon Musk bought Twitter, right? It was like, oh, we want freedom of speech and yada, yada, yada. He bought Twitter for the data to train Grok after he had us falling out with the ChatGPT people. What's the guy's name? Sam Altman. After they had their falling out, because Altman wants the robots to take over, which I think would be cool. You know, not necessarily fun after 5 minutes, but still cool. I'm a big fan of the Terminator movies. But he wants it to go that right way, where, you know, Elon Musk wants it to go another way. I don't happen to use Grok. I also don't happen to use X. I wasn't really a Twitter user beforehand, but some people like that feel. Twitter has like a personality. People who use Twitter, and Grok is trained on that personality. Some people just prefer that. Nothing wrong with it. So in any case, consider these for a right tool for the job, but always understand you're putting your stamp of approval on it. Don't submit anything that you aren't going to claim as yours. So use AI at your own risk, and probably don't use it as a counselor. If you're talking to AI about depression stuff, use that as a cry for help and go and talk, you know, come and talk to me. I work with a lot of students on this stuff. It'll be it'll be confidential, I promise you. But don't let AI talk you into stuff. All right. So 54 minutes into class, or actually what, 49 minutes into class. We're going to finally look at our Linux Hello World program. I asked the question last class as you're catching me up, right, on all this tech stuff I forgot over break. I asked the question, why do compilers need to know about the architecture as well as the operating system? Okay, and this goes with what we've been talking about today because this comes down to power tools. Okay, so a compiler, you reminded me last time, is something that takes a high-level language like Java and converts it into a low-level language like assembly code. Java bytecode, Microsoft Intermediate Language, Missile code, x86 assembly, okay, turns it into that. And it's ultimately that low-level language that is speaking call it the built-in programming language that knows how to talk directly to a CPU. So CPUs are collections of magic tricks. A CPU has built onto it all these little hardware circuits, and each one does something special. It's like a little tiny computer program built out of hardware that you feed some inputs into, and those come in through those pins, right? You look at the bottom of your processor, it's got a zillion pins on it. Those are your inputs and output stuff. So you get the inputs come in, it goes through the little hardware thing that's microscopic to the human eye because we've gotten so good at manufacturing these processors. I think right now the current tech is 3 nanometer technology. You've probably seen that with newest processors. It'll say 3 nm next to it. Before that, it was 5 nanometer, then 7 nanometer, blah, blah, blah. What is this really? This is how good we've gotten at printed circuit boards. How close can we get the microscopic wires to each other before they start interfering with each other? So it's the quality of our manufacturing process because our processors are not really changing their physical size. We're getting better at fitting more crap onto them, which means that we have more magic tricks or we have enhanced old magic tricks. That's what happens when a new processor comes down, you're shopping for a new computer and it's like, well, should I get last year's Core i7 or this year's Core i7? Because this year's Core i7 is up to 38% faster than last year's Core i7. Well, now you're getting into legalese. Yes, it probably technically is 38% faster on some very, very, very specific use case that may be something you never will do. But technically, that one piece has been upgraded on the latest architecture that is 38% faster than the previous one. But if you don't do that one little thing, what are you actually doing? You're spending an extra $500 on a processor is what you're actually doing. Because you otherwise have the same architecture as last time. Maybe it says it uses slightly less energy. I promise you, you will not spend $500 in the difference of energy across the lifetime of that processor. You'll spend more like $2 difference across the life of that processor. We're talking such tiny percentages when they say they extend battery life and stuff like that. So yeah. So in any case, when we ask the question, why do we need to know the architecture, what kind of CPU we have? Because that guy speaks a certain language. So if we take the CPUs that live inside of most of our computers now, because most of our computers are running Intel-based processors, and even for a long time, Apple was running Intel. Well, Apple was running PowerPC, then it was running Intel, which almost folded them, and then they were running their own processors again. Apple Silicon, right? Sounds really great, but what did they do? Apple's a rich company. They went out and bought a processor company, and now it's Apple Silicon. So those were the processors they were building for all the mobile phones. Because how many of you are Android users? Okay, so Android users, what kind of processors are in your phone? Come on, you're tech people. You should know your internet speed. You should know what CPUs you're carrying in your pocket. Snapdragon. So these are ARM processors, ARM. Okay, these are it's called reduced instruction set processors. So Snapdragons typically they're 8-core processors, right? Then you start looking into the more modern architecture for it. You find out that, okay, well, 6 of the cores are 4 of the cores are high performance cores. 2 of them are low performance. 2 other ones are ultra low performance, that use less energy because the goal is to preserve battery life. So yes, but not all those cores are created equal. Apple architecture, yes, it's a very similar type thing. They're also ARM processors, all those A processors, the A8 Bionic processor, just to make it sound cool, right? It's also an ARM processor, whatever. Well, Intel is not ARM processors. So the language, the low-level language that an Intel processor speaks, Core i7, that language, which is a superset of the x86 assembly language from the 1970s, it is one thing where the language, the individual instructions you can feed to an ARM processor, for example, Apple's M4 chip that's on their laptops, or their, what is it currently, the A13 Pro chip or something like that in the current iPhone, whatever it is. We're speaking to those are different languages. So a compiler needs to know that I'm going to turn this high-level code into a language that's understandable by the hardware this program is going to run on. Okay, if it's going to run on this Mac, it needs to be able to run on M4 chips. If it's going to run on your laptop, it's got to run on an Intel Core i5 or newer, whatever the architecture you have is. But it also needs to know about the operating system. And let's just look at this real quick. All right. So when we look at this, so this is a sample Hello World program in for Linux. So this would be a Linux computer that is running on a Intel-based architecture. So probably a Core i5 or something like that. So when we look down here, this is our assembler. We're picking a 64-bit ELF-based architecture, which is an x86 compatible architecture. Our output, this is our object file. This is our linker that's going to actually turn it into an executable. And here's us running that executable. So an executable, what happens there is it goes from high level to low level to machine code. The linker is what takes it to the zeros and ones. And those zeros and ones are what actually runs on the processor. How? Just like ASCII or Unicode. It says, execute instruction 000111001. And that happens to be the instruction for move something. Well, it requires 2 inputs. So maybe the next 2 bytes are those 2 inputs. Something like that's how it processes machine code, just like looking up stuff on ASCII or Unicode. All right. So it needs to know the architecture so it can produce the right language to speak to the processor. But it also needs to know the operating system. Why? Because that assembler wants to take advantage of as many power tools as it possibly can. It doesn't want to have to rewrite the book on how do I speak at the hardware level to your specific graphics card, which will speak to your specific monitor to actually get crap on the screen. Right? Instead, our assembly code is going to say, look, I'm going to rely on the operating system you're running. You're running Linux in this case. That's what we told it. We said, look, here's my program. We're going to compile it for Intel processors running the Linux operating system. Cool. So now I know here's all the commands the processor understands, and I know here's all the stuff that the Linux operating system can already do. For instance, it can print stuff to the screen. Now, when he installed his Linux operating system, it went through, it detected his graphics card, it installed all sorts of drivers and things like that. Maybe he had to install some special drivers for certain peripherals or something, but the operating system knows how to talk to the parts of his world, right? Knows how to talk to his GPU and things like that. So this low-level code is going to take advantage of that and say, I know the Linux operating system. I can just tell it to call one of its syswrite programs that knows how to talk to the GPU, that knows how to print something to the screen, rather than me having to do all the heavy lifting for it. So that's what's happening here. Go ahead.
So you're saying that compiler is what we're talking about, compiling architecture stuff.
And it needs to know the operating system. It needs to know both. For that reason we just talked about, we can see how it's using it here. So if I'm the Linux operating system, and I'm diving into this code, I'm expecting, if I'm the Linux operating system, you're trying to run this executable on my computer, I'm expecting this thing is supposed to run on this computer. So I'm expecting you compiled it right. Okay, but I'm going to jump in. I'm going to say, okay, well, what are we doing here? Just like functions. When you write a function, I might say, okay, write a function that takes two integers as a parameter and returns the larger of the two values, something like that. So now you have a function that has two inputs. Well, Linux has a function called syswrite that takes 4 inputs. 1, 2, 3, 4. Okay, and what it does is it expects that you're going to place the values for those inputs into very specific places. These are things that have already been documented by the Linux operating system. The Linux operating system says, look, I need 4 inputs to write something to the screen. I want you to put one of them in one hardware register. It's like a variable built out of hardware, a little piece of memory. So I want you to put one of those things here, another one of these things here, another one of these things here, another one of these things here. RAX, RDI, RSI, RDX are all hardware registers, variables built out of hardware. So as a programmer, we're going to go ahead and we're going to load those 4 places up before we tell Linux to call that function, because those inputs need to be there for that function to work. So what do? We say, okay, first thing, where am I writing to? This is standard output. The number 1 is, in this case, is associated with the monitor, standard output. Okay. Which stream am I writing out to? Let's see, we're doing a 1 there. Oh no, this is which output. This is what is the command that we're writing. So we're calling syswrite, which is command number 1. We are writing it to output stream 1, which is the monitor. What are we writing? We're writing our message. Message was defined down here as the string hello world. So that's what we're writing. And then how long is it? This is that base address thing where we're talking about arrays. So hello world is however many characters it is, 9, 10, whatever, you count them. 11 probably. Okay, so and how long is this? Is it? Then we're going to say, okay, I've loaded up the bases. Linux, go do your thing. So right here we are calling Linux to do its thing, and what it does is it immediately goes to RAX and says, what is it you want me to do? Well, I want you to do magic trick number 1, which happens to be syswrite. Linux says, okay, we're doing syswrite. I need 3 more things from you. Okay, what do I need? I need where am I writing it? I need what I'm writing, so base address of it, and I need how long it is, so I can make sure I jump through memory 1 character at a time and spit enough of those out on the screen. And then it goes and does it. Now it's on the screen. But it leveraged Linux to pull this off. Otherwise, we would have seen hundreds of lines of low-level code here to accomplish the stuff that the operating system, Linux, already knows how to do, write stuff out to your monitor. All right, so this compiler used the knowledge of the operating system this program is going to run on to leverage the power tools already built into that operating system rather than reinvent the wheel. Okay, so even though we're looking at what looks like more complex code, that looks like something that, oh, as a programmer, I would never want to do, the reality is a human being could write this, and this isn't as bad as it gets. Assembly coding used to be way worse, but now we can rely on our operating systems to effectively act as APIs to do all sorts of stuff for us. Secondly, when the program ends, it's going to exit. Notice what we do. We move something into RAX. The same thing we moved up here. But instead of saying I want to do magic trick 1, it's saying I want to do magic trick 60. It just so happens magic trick 60 is sys exit. End the program. Okay? Then it says, okay, well, you can also put in RDI a exit. Remember all our, actually, I think I've shown you C++ code where it returns like 0 at the end. So old programs, they would return either an error code or 0 if everything went to plan. So when you're exiting the program, you're saying, okay, I want to exit, and here is anything that went wrong. Otherwise, it'll just be filled with a 0. But if there's 20 different things that can go wrong, maybe I say 18. We crashed because problem 18 existed, and you have documentation that you've written with your program that says, oh, 18 means file not found or whatever it is. All right, that makes some sense. So a compiler needs to know about both of those things. It needs to know what architecture am I going after, and then what operating system is it running on, so I can generate code in the lowest common denominator that will run on that hardware and run on that operating system. All right, questions about any of that? Okay, so we'll come back on Tuesday. We're going to look at introduction to recursion, and then we're going to look at merge sort. So I will go ahead and well, we did this, so we'll just say Linux hello world here. When we're going to chapel front row, if anybody's interested.